Among the science experiments and hardware being delivered to the space station on the new Cygnus cargo craft is a special camera meant to record meteor showers to help us learn more about the behavior and composition of asteroids and comets that cross paths with the Earth. It's called the Meteor Experiment, and recently my colleague Dan Huot spoke with a payload developer, Michael Fortenberry, a principal engineer in the Space Science and Engineering Division at the Southwest Research Institute at San Antonio, Texas, and asked him what prompted the development of this experiment.
Well, Meteor's a collaboration between the Southwest Research Institute and the Chiba Institute of Technology in Japan. So our goal with this instrument is to use image analysis of meteors entering the Earth's atmosphere to provide information on chemical and physical properties of the meteors, like size, density, chemical composition. So to do that for meteor showers that are well known, and also during slow times to look for new meteor showers that possibly nobody's observed on the Earth.
And there's something special about the camera you guys are going to be using. What can this camera capture that others can't necessarily?
Well, this camera it's a pretty standard high definition television camera that can capture normal video. But in addition, we have a customized lens that we can put diffraction gratings into. And the diffraction gratings are like tiny lines with tiny prisms that will take the light coming into the lens and split it into different wavelengths. And then we can look at the different wavelengths of light coming in as the meteor enters the atmosphere and determine what the chemical composition of the meteor is and what the percentage of each chemical on the meteor is. And right now, we can do that with this lens for 4 different elements.
So where exactly is the camera going to be installed on the station? And are the crew members on board going to have interaction with it? How's it going to be operated?
Well, the camera gets installed in it's called the WORF, like the Klingon security officer in the Next Generation Star Trek. It's the Windows Observational Research Facility in the U.S. National Lab. And the WORF is an express rack with a window that looks down on the Earth. So the crew will be involved, but mainly for doing the installation and then for helping us maintain the camera, for doing things like changing out diffraction gratings and doing focus adjustments and replacing hard drives, things like that. So most of the time, the crew will install the instrument and then it'll be operated from the ground primarily. And then when we need something done to it, the crew will help us out and they'll go in and swap out a diffraction grating or change out a hard drive.
And then for your team, this launch is going to be special because this has kind of been a long road for you guys. This is going to be your 3rd attempt to send Meteor to the International Space Station. What's it been like to kind of overcome these setbacks and get the hardware ready for the 3rd time now?
It's been a long road. We've had a camera destroyed the two previous times. This is the 3rd time's a charm for us. When we had the first one destroyed, we had a ground spare that we prepared for flight, so that went pretty fast. After the second one was destroyed, the science team started looking at the instrument and decided that we could actually, since we had to have new camera and lens built anyway, we could actually re-engineer some of the lens assembly. So we re-engineered some of the lens assembly to change the way the diffraction gratings are installed and make everything a little tighter tolerance and a little easier to adjust and make it easier for the crew to install. So we're very hopeful that this 3rd attempt is going to be successful.
All right. Well, like you said, I'm sure the 3rd time will be the charm. Now, for Meteor, you've already targeted a couple of big events. What's going to be the first big event that you guys are looking forward to?
Well, the very first one that occurs right after we get on orbit is the Lyrids. And then we get the Aquarids after that. And then the really big one, which hopefully when we get installed at the end of April, we'll do a little bit of checkout over the first month or so. And then we'll be really ready in August for the Perseids, which is the first big meteor shower. And that's probably the one that most people are familiar with, that and the Leonids in November, the really big ones that are really popular on the ground just because of the number of meteors that enter the atmosphere.
And so after you guys get the video, after it's all recorded, how does it get back down here to the ground, and what do you end up doing with that data? What are we really looking to learn from this experiment?
Yeah. Well, like I said, we're looking to learn, more about meteors and more about their size, their density, their composition, and what that'll tell us is uh, more about the comets that most of the meteors came from. So most of the meteor showers that we're familiar with, like the Perseids and the Leonids, are all of those meteors came from a specific comet. So if you know more about the meteors, you know more about the comet they came from. And so as far as getting the data back, we have two ways to get the data back. Every day, as Meteor looks down during the night passes from the station and takes data, we will record data, and the software on board will go through and look through that and try to find meteors, and basically send us a list of times that it thinks it found meteors and little bitty short video clips to show what the meteors look like. And then if we find some that are really interesting, we can tell the software to download a larger, higher resolution video of that. But that's still only a fraction of the data. So most of the data is stored on, we've got 35 hard drives total. So most of the data is stored on hard drives, and that'll be sent back as we fill up a hard drive, it'll be sent back down to the Earth with a return vehicle, and we'll look at it on the ground also.
All right. Well, again, Michael Fortenberry, one of the primary team members for the Meteor experiment and one of the principal engineers at the Space Science and Engineering Division at the Southwest Research Institute in San Antonio, Texas. Thanks so much for joining me today. And again, third time's a charm. Really looking forward to that launch and looking forward to getting some video and seeing some of those meteors back down here on the ground.
Thanks a lot.